Today we're going to talk about exponential equations and interpreting them. Today we're going to really talk about compound interest, okay? So compound interest is interest, okay? Added to the principal. Remember the principal here? The principal. This means initial. Okay, so it's principal. This means that the interest also earns interest from the point, that point forward. We call this compounding interest. Compounding interest. Okay, so it says consider the following exponential equation. So this is just like the exponential, just the letters have changed. Okay, so this is an example of exponential growth. Go over here. So it's an example of exponential growth. Okay, we know that from this plus sign right there. Okay. F in the equation stands for our future values, our future value of the investment. P stands for the initial or the principal amount that we start with. R stands for our rate of interest. Okay, then in decimal form, that's a key thing, in decimal form. And T represents time in years. And the main thing about that, the number in front of this T here, this number out here, that represents the amount of things you need. So if you have 1 year, the number in front would be 1. If you have 2 years or 2 months, the number would be 2. If you did 12 months, the number would be 12. If you did 365 days, that number would be 365. Alright, so it says, I have the equation 1.039 to the 2t. Okay, and what it's asking us to find is the yearly interest rate. So right now that number is 2, and we need the number in front of that t to be 1. So to get rid of this 2, we're going to multiply or divide this by 1/2. Okay? The one thing about this exponential function here is whatever I do out here, I have to put the flip version of it here. So here would be squared, or 2 over 1. Okay, so that will get rid of this 2 and make that a regular t, or 1t. And we do 1.039 squared, and I get 1.08 to the t power. That's down to the t. And it's asking us for the rate. So remember, this can split to 1 plus 0.08 to the t. And our rate, or our r, is 0.08, or 8%. Okay, then it wants the monthly interest rate. So again, it's 1.039 to the 2t. And we need to make this 2 here now a 12, because we're doing 12 months, because we're looking for the monthly interest rate. Okay, so to do that, we're going to multiply by 6. So in here, we're going to raise this to the 1 over 6 power, because we always do the flip version of what we do on the outside. So now I'm going to have this. So it's 1.039 to the 1/6 power. And I get 1.0064 to the 12t. Again, that interest rate will split to this. And because that's now 12, we're good. So our R is going to be 0.0064, or 0.64%. Okay, it says a client invested $1,500. The interest is calculated quarterly. Okay, write the function. So remember, the F equals P times 1 plus R to the t. We know what this is from up above. This is that 1.039 to the 2t. Our F is simply this 1,500, or our P is that 1,500, because that's our initial. We don't know F, so it's F equals that. Okay? But We're compounding quarterly. So what we need is we need to make this, because 12 divided by 4 gives us 3 here. So that means every 3 months is quarterly. So we need to make this 2 here a 3. So what we're going to do is we're going to multiply this by 3 over 2. And why we chose that, we know the 2's will cancel out, leaving me with just that 3. Remember, whatever I do inside, I have to use the raised flip version of this, so it's going to be raised to the 2 over 3. Okay, so 1.039 raised to the 2 divided by 3 is going to give me 1.026 to the 3t, and then bring down my 1500, and instead of write a function, there's my function where you're all set. Okay, let's do another one. Okay, so we're getting this 1.042 raised to the 5t. And instead we're doing a yearly interest rate, so we need to make this number here 1. So we're going to multiply by 1 over 5. And whatever I do, I need to the flip here, so that's going to be to the 5th. So 1.042 to the raised to the 5th is 1.228. Okay, so my R would equal 0.228 or 22.8%. Okay. Next one is the daily. Okay, so it's 1.042 raised to 5t. We need to make this 5 365, because it's 365 days a year, so let's do 365 divided by 5. That gives me 73. So we're going to multiply this by 73, which means in here I'm going to raise it to the 1 over 73 power. Okay, so let's do that. 1.042 raised to the 1 divided by 73. Then I get 1.00056,365t. So we got my R is 0.00056 or 0.056%. Okay. Assume that the interest compounded daily, I'll leave what charges $5,000 on the credit card, write a function. Alright, so we got F equals P times 1 plus R to the T. It's compounded daily here, so we know this daily is 1.00056 to the 365 T. That's from the problem above. And we know that we are starting with an initial of 5,000, so that's going to be my P. So our function is F equals 5,000 times 1.0500056 to 365t. Okay. This is the company, so let's start with my function that we just had. Okay. Company offers 3 months with no payments due. Okay, so we need to figure out how much interest is owed after 30 days. Okay, so we know it's 30 days a month, or 3 months, 365t is going to become 90. So what we're basically going to have, we chose, because it's 30 days a month, that's what it tells us, and we're doing it in 3 months. So this is raised to the 90th power, so we're going to do that, 1.00056 raised to the 90th. Multiply that by the 5,000. And we get F is equal to 5,258.38. But that's not what it asks us for. It asks us for the interest rate. The interest rate, or R, is going to equal $258.38. That is how much interest was added on in the 3 months that it just sat there. All right, last couple. Okay. The expression, it says 1.016 to the t over 4. And it says we need to find the yearly interest rate. Okay, so it means we need to make the number here 1. So we need to multiply both of these by 4 to get rid of that exponent. So here I'm going to do 1 over 4. 1.016 to the 1 over 4 is 1.004 to the t. So our r would be 0.004 or 0.4%. Alright, the customer invests $600. Write a function that should compounded monthly. Write a function that is showing. So first we need to take this 1.016, that's multiplied by t over 4, and we need to make this number 12. So what times 4, what's 48? Or 12 times 4 would be 48, so that means I'm going to multiply these both by 48. This one I'm going to do 1 over 48, because it's always the flipped. Okay, so we're going to do 1.016 raised to the 1 divided by 48, and I get 1.00033. That's going to be down to the 12t. That's going to give me 12 there. Okay. Our principal, or our initial, is right here of $600. So it's 600 times that. There is our function for the monthly.